Hello, Chemistry 300 students. Mr. Parker here, and this is Screencast session number 2, dealing with atoms, compounds, and mixtures for Unit 2 that we've been covering on matter. In the first one, we looked at with the states of matter, chemical properties, physical properties, and chemical and physical change. In this one, we're going to take a little bit closer look at atoms, compounds, and some mixtures, and some of the characteristics that we see there. Okay, so in the first one slide here, we're kind of redefine what matter means. Basically, matter is anything that takes up space, has mass. All right, so you can see the universe here, and it's made up of what we call atoms. Okay, and atoms in chemistry, atoms are the basic building blocks of these of this matter that we're talking about. Okay, so for instance, if we look here at this particular atom, which we refer to as carbon, okay. You can see here that the carbon is made up of a number of electrons on this outer valence shells, and then on the inside of this, found in the nucleus, you'll find neutrons and the protons. Okay, this particular one has the 6 protons and 6 neutrons, and then it has the number of electrons in the outer shells. And we'll go in further into this, but so this is a carbon atom. It's made up it's matter. It's made up of these atoms that will build it up. Okay. So kind of defining what elements are. It's a substance made up of one kind of atom. There's a little more than 100 of these known elements today. Majority of them are found naturally. Some of them are made just in a laboratory. Okay. Pure substances that cannot be separated into simpler substances by physical or chemical means. All right. So these elements cannot be broken down any further. Okay, by any way, chemically or physically. And the 6 different elements that make up about 97% of our body, okay, or almost all living things. And the 6 that you can see here, we have carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. This might be familiar from maybe your basic bio class. We've covered this many times. These are the atoms or elements that make up all living organisms. Okay. So here, what you can see is the periodic table of elements, and we'll get into the periodic table and all the characteristics and basically the flow of how the periodic table is all set up. But everything you see on these periodic table, these are all elements. Okay, these are all symbols that are representing elements that cannot be broken down any further chemically or physically due to the fact of their properties. And kind of giving you a little bit of background, so you can see here. What you have is on top is what we refer to as the atomic number. We have the atomic symbol for whatever element. In this particular case, we're talking about helium, and then the mass of that particular element that we're looking at. So you can see here we don't have the masses involved, but we do have the atomic number that it represents there. Okay, so you can see here gives information in particular about that particular element. And again, we'll get into the specifics about the periodic table coming up here within the next couple of units. Okay. So what types of elements are there? There's what we refer to as a monatomic, diatomic, and polyatomic. And if you remember the prefixes, mono meaning 1, di meaning 2, and poly meaning more than 2 or many. These diatomic elements, okay, they're composed of 2 of the same element. And then we have what we call polyatomic elements or polyatomic molecules, and they're composed of more than 2 atoms. All right. So, for example, as you can see going across here, these are all represent diatomic, okay, molecules. You can see we have hydrogen, nitrogen. The only way these elements are present, okay, are when they're bonded to themselves in a molecule form, okay, or molecular form. And then we have some polyatomic molecules, which are phosphorus and sulfur, and you can kind of see their arrangement here. And then you can see where they're found on the periodic table. Okay. So again, these top ones are your diatomic, as you can see here, and these are referred to your polyatomic. And that's how these elements exist. They have to be in molecular form, either a very simpler one, the diatomic, or the more complex, the polyatomic molecule. Okay. So moving on to matter, a little bit more about matter. We have matter is made up of atoms. Okay. We know that. We've talked about that. But they're also basically, they're made up in different combinations. Okay, you could have what we refer to as molecules or compounds. Okay, so let's first talk a little bit about compounds. Okay, compounds are composed of two or more different elements joined together by chemical bonds. So this is the key here. We're looking at compounds are different elements bonded together chemically. All right, they're done in specific ratios. Okay, so they complement each other. They have a chemical formula, and they can be separated by chemical means. Okay, that's the only way we can separate them is by chemical means. So they're different elements joined together chemically, has formulas, there's specific ratios, and they can be separated chemically. Okay, so for instance, we have water here. We have this ratio of 1 oxygen to 2 hydrogen. Okay, so we have two different elements. Another example here is DNA. Okay, the deoxyribonucleic acid, and we're looking at the nitrogen and phosphorus groups. Okay, and how they're combined together. So this is what we refer to as a compound because we have different elements, and you can see that by the different colors that are represented within this DNA molecule. Okay, and now when we look at the molecule here, how we define it is formed when two or more atoms are joined together. Okay, all molecules are not considered to be compounds though, because if we have these diatomic elements, okay, that were bonded together that we talked about previously, they are not different. Some of those are not combined, they're the same elements that are combined. So like we had N2, all right? So those that are the same, okay, bonded together, are called molecules, but they are not called compounds. Now, so that's what you can see here can be a combination of the same elements or different elements. All right, so here, this is considered a molecule, okay? It's also considered a compound because it has different elements. We have oxygen and hydrogen. When we're looking at these here, like hydrogen by itself, this is considered a molecule, but it's not considered to be a compound. And you have oxygen, nitrogen, and chlorine. Again, they are all molecules, but they are not considered to be compounds. Okay, and then DNA here is considered to be a molecule and a compound due to the fact of having the different elements present. All right, so moving into a little bit more about mixtures. Okay, a mixture is a combination of two or more substances that are not chemically combined. Okay, the substances are basically held together by a physical force. They can be separated physically. Each item retains its properties in the mixture, and there's no chemical change that takes place. So when we have something that's a mixture, we're not changing the chemical properties with it. We might be changing physical properties, but we are not changing the chemical properties. They still have the same properties. So looking at here, you can see some of the different mixtures. This is mixtures of two different elements represented by the two different colors. Here you have basically some diatomic elements, okay, or molecules, and then you have some individual green elements mixed together. This is basically a mixture of two diatomic molecules. And then here we have basically two types of molecules. We have, you can see here the green and pink together, and then you have the diatomic pinks linked together. So this is molecules of compound, okay? And these are all mixtures, different types of mixtures. And we're not changing their chemical composition, but we are combining them together in a particular mixture. So looking here at the difference between a mixture and a compound, you can see some of the properties. I'll have you kind of read through those on your own, and then you can kind of see some of the different examples here what a mixture is and where compounds are not. Okay, so remember we're talking about mixture. Okay, they withstand their own chemical properties. They're not changing properties. Whereas a compound, you're changing chemical properties when you bond the elements together. Okay, so now looking at an element versus mixture versus compounds. All right, you can see here we have just our monatomic element. Here we have diatomic elements, basically a diatomic molecule bonded together. We have our mixtures that we already went through, and then we have just our compounds. These are referred to as compounds and molecules because they have different elements joined together. All right, so classifying these mixtures. There's two ways to classify a mixture. All right, there's what we refer to as heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures, what we're looking at here is basically the molecules are unevenly distributed. Okay, and then in homogeneous mixtures, the molecules are evenly distributed, and you can't. Basically, it looks like one solution or one mixture. All right, so we'll take a look at that here. Looking at the diagram here, when we talk about here's your elements and compounds, now let's get into the idea of a mixture. And remember, we're not changing the physical properties here with the mixture. You have your homogeneous, okay, where things are evenly spread out, and you have your heterogeneous, where you will find that some are clumped in certain areas and they're not evenly spread out between them. So if you notice here, the molecules are spread out amongst each other, and here the molecules are kind of divided. You have half on top of the one molecule and half on the bottom of the second molecule that we're looking at, or the compound that we're looking at. Okay, another picture for you to see this. Here's the heterogeneous mixture. They're talking about wet sand. So you would have sand and water, all right, but they're heterogeneous, meaning they're not uniform throughout. And then here they have tea with sugar, okay. So tea and sugar, so the sugar has been dispersed evenly throughout the tea. So this is what we refer to as a homogeneous mixture. And again, the sea salt or seawater or wet sand is going to be referred to as a heterogeneous mixture. All right, so we had mixtures. Now moving into the idea of what a solution, okay, a solution is a liquid mixture in which the minor component, the solute, is uniformly distributed within the major component called the solvent. Now we've talked about these before, a solution before, what a solute and a solvent is. The solute is what's getting dissolved, and the solvent is what's being dissolved, okay? So some characteristics of these solutions is that it contains small particles. They're transparent, meaning you can see through them, and they do not separate evenly. They do not separate even by like filtration or a semi-impermeable membrane. Okay, so filtration, I'm sure using like filter paper, kind of think about if you ever made coffee, you put the grinds of the coffee into the dish where the cup that the water is going to go through. That's kind of your filter, and we'll take a look at that in a second here. And semi-impermeable, okay, if you remember from biology class, it's some things can pass through, some things can't, okay? And it does not scatter light. What that means is if I take a flashlight, it's called the Tyndall effect. If I shine the light at the solution, will the light scatter? Kind of like if you're driving in a car and it's foggy out, the lights kind of scatter. Well, with solutions, the light does not. The light will be able to shine right through and it doesn't get deflected in any manner. Okay? There's another type called a colloid, okay, and this falls in between the solution and the next thing we'll talk about is a suspension. These are usually they're homogeneous, meaning the molecules are spread out evenly or uniformly. Okay, some characteristics about it is that usually have mid-sized or medium-sized particles. They cannot be separated by filtration. However, if you see here, however, they do scatter light. They do show the Tyndall effect. Okay, so remember, solutions cannot be filtrated, and they do not scatter light, whereas colloids are not filtered, but they can show the Tyndall effect. Okay, and this kind of just shows you some different examples, fogs, clouds, so on and so forth, going through some of the different examples of what colloids are, some common things that you'd be familiar with, and might give you a better image or visual of what a colloid is. Okay, and the last one is a suspension. Okay, these have very large particles in them. They're not uniformly distributed, so they're heterogeneous mixtures. The substances that are found in them usually settle out. They can be separated by filtration, and they must be stirred to keep the substances suspended. Blood platelets, muddy water, salad dressings, that kind of stuff that will easily separate from each other. These are what we could refer to as suspensions. Okay. So in this picture here, what we're kind of showing you is the solutions, everything's evenly distributed, and so the colloids are. Okay, whereas when we're talking about suspensions, you're going to find a heterogeneous mixture. Basically, things are going to be separating from each other. And then this one kind of shows you the different processes of possibly separating the mixture apart into their individual components. Here we just went through that diagram. Here they're doing a filtration process. Okay, and you can see some colloids. Basically, you see the solutions are going through the filter. Okay, they don't get caught on the filter paper. Where very few colloids do. Okay, but the majority of them will actually go through the filter paper. And then when we talk about semi-impermeable membrane, or something that some things can pass through and some cannot, okay, the solutions can pass through, but the colloids, okay, and the suspensions are going to get caught up within that membrane. Okay, so it won't pass through those membranes. Okay, and then again, this is just kind of going through summarizing the difference between solutions, colloids, and suspensions, looking at the particles, settling happen, and separations do or do not happen. Okay, so definitely this is a good little summary slide for you to kind of take a look at. All right, so just a quick example. Mixtures, what type? So a mayonnaise would be a colloid, muddy water would be a solution, because we're able to separate those out. To fog, a colloid shows that Tyndall effect. You have your saltwater solution. Okay, we could separate the two components of that, salt and water. And the Italian dressing is the suspension. It's a heterogeneous mixture. Things are not uniformly distributed throughout them. All right, so some ways of separating mixtures. We've talked about these several times already. I've mentioned filtration, mentioned the idea of semi-permeable membranes. There's also something called distillation that we can use to separate some of this stuff. So some can be separated easily, okay, like rocks and marbles, iron fillings and sulfur. We can use a magnet to separate them between each other. One reacts with the magnet, one doesn't, right? Okay, we can also look at the differences in the physical properties, okay, that will help us separate them. And two things that I've mentioned filtration before, and the one we're going to take a look at is also distillation, which is a process of separating your solution apart. Okay, so distillation is real quick. It works for solutions. It takes advantage of the different boiling points, the two substances that you have in it. Okay, so as you can see in this particular diagram, we have this heat source. We start boiling the substance. It creates the vapor, so because of the difference in boiling points. Okay, one of the substances is going to boil faster and become a vapor faster. And what's going to happen is it's going to hit this tube, okay, and we're going to have water running through it, and this what's referred to as a condenser, because this water is cold and this vapor is heated up. Once that's once that warm vapor hits the condenser tube, it's going to condense back into a liquid form, and that's going to drop off into here. So basically what we're going to have is eventually what we'll have left is the one substance with the higher boiling point. Okay, will be left here, and the lower boiling point that we've reached is going to condense and filter off into our distillate here, and it's going to separate our two compounds or elements that we have within this solution by separating them due to the fact of their boiling point. Okay, and this is another one kind of showing the same idea. We have the heating up the substance. We have this condenser here. You can see the water vapors are occurring. Okay, eventually hits the condenser, it cools it, the vapor, and eventually you have the water that's been distilled, and basically it's got rid of the other substance that we didn't want. It basically, I think, it cleaned the water out. Okay, so now we have just pure water molecules here versus when down here we did not. All right, the last thing we have to talk about real quick is when we look at these solutions and looking at suspensions and other items, we need to figure out what the percent mass composition is, okay? How much solute is present within the whole entire solution. And we did this when we were looking back at the egg lab, okay, where we were looking at the composition of how much salt was in this particular water. And how we do that is we take the mass of the solute, so what's being dissolved, and we divide it by the mass of the solution, or the mass of the entire mixture that we have, okay? So it's your mass of your solute plus your mass of your solvent, and then you divide that and then you multiply by 100, okay? And this is basically a way to describe the amount of solute that's been found in the solution. Perfect example we can look at is Kool-Aid, okay? Your Kool-Aid powder, okay, that's being dissolved, the solid that's being dissolved is going to be our solute, and then your solvent is going to be the water that's doing the dissolving in the process. Okay? So, for instance, here's a sample problem for you. We have a solution that has 15 grams of ethanol and 85 grams of a solution. What is the percent? What is the percent mass of this particular solution? All right. So, first thing is we have our equation. We have our mass solution, mass of the solute, which would be this that's being dissolved in it, okay, our ethanol, and then we have the total mass of our solution. And as we go into to figure out the work, you take 15 grams of ethanol divided by the total mass of the solution, and then you times it by 100, and you end up that it's basically telling you that we have this 15 grams of ethanol makes up 17.64% of the whole entire solution. Okay. So This was screencast session number 2 on atoms, compounds, and mixtures. And what I will do is I will end the screencast here, but I will have a little review video that will last a couple minutes on the end, and it will review all the concepts that we've talked about. So this was screencast session number 2 on atoms, compounds, and mixtures. I hope you learned something from it.
Hello there. Have you ever wondered what an atom is? Well, I'm about to tell you. I will also tell you what a molecule, element, compound, mixture and solution is. Everything around us is made from atoms. From the grass to the road. This is an atom. It is composed of neutrons and protons, which are in the nucleus. Electrons fly around the nucleus. Each atom has different amounts of protons and electrons. If two or more atoms are joined together by chemical bonds, it is called a molecule. If the two or more atoms are the same, it is called an element. Oxygen is an atom, but when two oxygen atoms are joined together, a molecule of an element is formed. It's a molecule because there are two or more atoms, and it's an element because they are the same. A compound is made of two or more different atoms joined together. Water is a compound because it is made of two hydrogen and one oxygen atom. Now let's move off the subject chemically bonded substances. A mixture is basically what it sounds like. It is when two or more different substances are mixed together but not chemically combined. A solution is like a mixture but only composed of one phase. A solvent is the substance that does the dissolving, and the solute is what gets dissolved. If you mix water and salt, the salt is dissolved in the water. The water is the solvent and the salt is the solute. The new substance is saline water, but the salt and the water have not been chemically combined, so they can be separated again. Well, that was the basics of atoms. I hope you enjoyed and learned something. Well, that is all from me now, so goodbye.